know everything. Now, in continuation of last class, today we are going to discuss about the uh, third normal form. Here, already I told you earlier, if the given relation is in a third normal form, if you want to check, before you need to check that given relation is must be in a second normal form as well as first normal form. So that only you are going to check third normal form properties. You don't directly check the third normal form properties. The first, that relation must be in a second normal form, and as well as that relation must be in a first normal form. So that only we can apply third normal form rules. So before jumping into the third normal form uh, discussion or maybe the implementation, we know that must be a second normal form and first normal form. Can anyone tell me what is the second normal form? What exactly? Any one of you, please. What is the second normal form? Quickly, don't waste the time.
All non-key attributes must be depending on key attributes.
Abhilash, can you repeat? Your voice is not clear. Can you repeat once?
All non-key attributes must be depending on key attributes, or in other words, it must be only full functional dependency.
Yeah, right. Your second normal form always supports only the full functional dependency and it avoids the partial functional dependency. If any partial functional dependency is there in the relation, now the second normal form is going to apply decomposition of those particular partial functional dependency attributes to separate a table. Like that, we need to apply second normal form. And sometimes even that partial functional dependency comes only because of non-key attribute is depending on another non-key attribute. So that is what exactly the partial functional dependency. Because if any partial functional dependency is there in your relation, there compulsory there is a non-key attribute depending on another non-key attribute. There is no key attribute in that dependency mechanism. But if you know, if any functional dependency is having based on the key attribute, compulsory it is a full functional dependency. Because if it is a, for example, if it is a student hall ticket number is a key attribute, you know very well, primary key. Now remaining all attributes are depending. That's what is a full functional dependency. It means all non-key attributes are depending on key attribute. That is what exactly we can tell second normal form. Correct? Is it clear, everyone? Again?
Yes, sir.
Yeah. Now, if the given relation is in a second normal form, then again you need to check first normal form. So that only we can apply the third normal form. Now that relation you need to check that is in a first normal form or not. So can you tell that given relation is in a first normal form or not? How to know? What is the condition for first normal form?
All attributes
The
are atomic.
moment
Can you repeat any one of you?
All attributes are atomic.
Yeah. In the relation, all attributes must be atomic. Means all attributes in a relation must be accept or must contain only single value. It contains only single valued attributes. So that remaining things, anything is there, you need to remove that so that your given relation is in a first normal form. Now I think everyone is understood first normal form and second normal form. Correct? Yes or no? Hello? Everyone is clear about first normal form and second normal form, right?
Yes, sir. Got it, sir. Yeah.
Along with that, one more point also we discussed full functional dependency and partial functional dependency in the last class very clearly. All of you clear about this? Full functional dependency. What is full functional dependency? What is partial functional dependency? Because sometimes they will ask the questions on this indirectly. All of you clear about that? What is full functional dependency? What is partial functional
Yes,
dependency?
sir.
Yeah. Now, okay, good. Now, today we are going to discuss. We are going to discuss about the third normal form. Here, already I told you, third normal form. The given relation is in a third normal form. Means that must be in a first normal form and second normal form. And third normal form is going to tell it never accept transitive dependency or trivial dependency. Here, that is a very important point. Remember, here what is transitive dependency, what is trivial dependency, we will discuss. Already we know what is the trivial transitive dependency. Any one of you tell me? Any one of you, please? What is transitivity? Already you know. What is transitivity? Hello? Armstrong axioms we discussed in the functional dependencies. What is transitivity? Hello? Your mathematical rules only. We discussed it so many times already. You know that. It is not a new thing. What is transitivity? No one is responding.
So like it's like attaining functional dependency using some indirect relationships.
Not okay, but exactly I given the definition with example in the Armstrong axioms. Okay, critically okay, but exactly tell me, any one of you. Transitivity means you are not following, you are not preparing. Just previous class we are remembering, 2 days back, 3 days back classes you are not remembering means you are not analyzing and you are not practicing the things. Any one of you, transitivity? Yogita, are you there? Can you tell what is the transitivity rule?
Yes, sir.
What is the transitivity rule? Yeah, I told you many times again, you people are, I don't know. If you are forgetting means that is not right. Here, if in a relation, if someone is texted, I am checking. Yes, Abhilash Muva, right. A determines to B, B determines to C, then A determines to C, right. Here, if your relation is having a functional dependencies like X determines to Y, and one more functional dependency is Y determines to Z. Then as per the transitivity rule, you can write directly X determines to Z. This is what exactly the transitivity. Your Abhilash is given right answer. Clear this? Now clear this. Hello? Hello?
Yes, sir. Yes.
Yeah. Now this is what exactly the transitivity. Now third normal form is going to avoid the transitivity rule. If any transitivity is identified in a relation, now you need to decompose. The first is when you want to check the third normal form, you need to check the relation must be in the first normal form, second normal form, and if it is in a second normal form, if that relation is having any transitivity, that transitivity you must be avoid because third normal form never accept the transitivity. Sometimes it is called as trivial dependency, transitivity dependency, or trivial dependency. The transitivity rule is if relation contains, if R relation contains, if X determines to Y functional dependency as well as Y determines to Z functional dependency. So as per the transitivity, you can write X determines to Z directly. Means if your relation contains x determines to y and y determines to z, instead of using x determines to z, you can take directly x determines to z is separate table. That is what the normalization you need to do for the third normal form. All of you clear this? Third normal form definition is clear. All of you clear about this third normal form? Hello?
Yes,
Hello?
sir.
Only one or two guys are responding. Remaining people, morning. All of you clear about third normal form?
Yes.
Yes,
Yeah.
sir.
Yes, sir.
Now coming to again with examples and some theoretical information I am going to discuss. Now as I told just now, a relation schema R, if it is R, a given relation schema R is in a third normal form. If it is in the first normal form as well as the second normal form, as I told you, that must be in the first normal form and that must be in the second normal form. And for all non-trivial functional dependencies of a place, the meaning is non-trivial transitivity. It is going to avoid the trivial functional dependency. Your avoiding of trivial functional dependency is, you can tell, non-trivial. Non-trivial means it is avoiding the trivial functional dependency. Please don't confuse. Okay, non-trivial, trivial or transitivity. Same. Please, those are the synonym words. Okay, non-trivial functional dependencies is in F place of the form X determines to A. Either X contains a primary key, either X contains a, X is a set of attributes. That's why X contains a any primary key. X is a super key. If it is a X is a super key, then X contains a primary key, or A is a primary key attribute. Here, in any case, here maybe you will get transitivity or functional dependencies. That's why you can avoid the non-trivial functional dependencies. The third normal form is based on the concept of transitivity dependency. Just now we discussed about that. The transitivity dependency. What is the meaning of transitivity dependency? Already I told you very clearly. A functional dependency X determines to Y in a relation schema R is a transitive dependency if there is a set of attributes Z that is neither a candidate key, very important this information, nor a subset of key of R, and both X determines to Z and Z determines to Y satisfy. Means this Z is a candidate key. So this is the meaning actually. So that it never accepts the candidate key. So that we can write directly X determines to clear. Here, as per transitivity rule, x determines to y, x determines to z, z determines to y, then you can write directly x determines to y. Here, when this is going to accept third normal form, here there is no chance of the candidate key. When you are going to write x determines to z, z determines to y, means that z is a candidate key. Just we are avoiding that here indirectly, so that we can write directly here x determines to y as per the transitive dependency. Means we are avoiding the non-trivial dependency. Are you clear? Are you clear this?
Yes, sir.
Yeah. In simple third normal form, another definition, all functional dependencies, every left hand side attribute should be compulsory a primary key. If you write x determines to y, yeah, this x must be a primary key, or it means simply removing transitivity dependency. Otherwise, if it is a left side must be a primary key, otherwise you can remove the transitivity dependency. You know what is the meaning of transitivity dependency? Again, I am telling, if your relation contains functional dependencies like x determines to y, y determines to z, As per the transitive dependency, you can write directly X determines to Z. That is what the transitivity rule. Our third normal form is not supported. Directly, you can write X determines to Z. According to the card rule, already I told you, here we are doing as per the card rule only. A relation schema R is in a third normal form if it satisfies second normal form and no non-key attribute of R in transitive dependency on the primary key. Just now, whatever you discussed just now. Here, some of the examples and definitions again we will discuss as per the book and as per the real-time scenarios. A relation will be in third normal form if it is in a second and not contain any transitivity partial dependency. The third normal form is used to reduce the data duplication and it is also used to achieve the data integrity. If there is no transitive dependency for non-prime attributes, then the relation must be in third normal form. If that is, a relation is in third normal form if it holds at least one of the following condition for every non-trivial functional dependency, that is X determines to Y. The meaning is if you write X determines to Y, the meaning is maybe X is a super key. So this X is a super key. If it is a super key means all other Y attributes are depending on X. That is the meaning. Super key means all attributes are going to involve to identify the particular tuple. That is called super key. Means all attributes are going to participate. So that all attributes are participating means here in this super key contains even primary key also. So that X is a super key. When if you write X determines to Y in a third normal form, any one of the condition must be uh, true. If the first condition, if it is like this, then it is a third normal form. Otherwise, Y is a prime attribute. Here, Y is a prime attribute. That is, each element of Y is part of some candidate key. Yes. Here, each element of Y is part of some candidate key. It is a prime attribute. It is also a key. It is a part of some candidate key. Here, like that, if it is there, the third normal form is going to satisfy. Here, this is the meaning. All of you clear? All of you clear about this? If it is clear, I
Yes,
will
sir.
go with examples. Yeah, right. If there are any doubts, please ask me. Even you people are having any doubts with second normal form? Because I forgot to ask. Is there any doubt in the second normal form? Hello? Is there any clarification is required in the second normal form? Hello? Time is running. Is there any problem or doubt in the second normal form? I need response.
No, sir, no doubts.
Right. Now, all of you clear about third normal form definition? All of you clear about third normal form definition?
Yes, sir.
Yeah. Now I will
Yes, sir.
yeah, I will give the examples for satisfying of this this third normal form definition. The first example, just observe employee details. This is the employee table. Here we have employee ID, employee name, employee zip code, employee state, employee city. When you observe here employee ID is a primary key. Yes or no? Yes or no?
Sir.
Yeah.
Yes,
Now,
sir.
if remaining all attributes are going to depending on the primary key, that is a common phenomena. So that we can write employee ID as a key attribute, separate one, and employee ID with employee ID with employee name and employee zip, because here all combination of attributes are going to depending on employee ID. Yes or no? Yes or no? Hello?
Yes, sir.
Yeah. So that we can feel employee ID is sharing everywhere, multiple, right? Here, multiple key attributes, multiple key attributes are coming. So that here the super key is nothing but all attributes are going to involve, all these attributes are going to involve, that is a super key. If you take only part of the attributes, for example, employee ID, employee name, now that is a candidate key. Yes or no? Yes or no?
Yes, sir.
Now, as our observation, all attributes are involving, you can take this is a super key. Now, everywhere our employee ID is involving, so that it is a only employee ID is, you can consider as a candidate key. Now, in this given table, if you are going to observe, here employee ID is a non-prime. Why? Because I will tell you. Here, employee state and employee city. So these are the two attributes. Depends on employee zip code. Yes or no? Then you can write employee zip determines to employee state and employee city. Yes or no? Employee state and employee city is depending on employee zip. Zip code means pin code. Otherwise, you can take it a pin. If you are confusing, you take pin. Employee state and city depending on pin number or not, pin code number or not.
Yes,
In
sir.
foreign countries, it is called as zip. Especially in India, we are calling as pin number, pin code. Yes or no?
Yes, sir.
Yeah. So that we can write a functional dependency. How we can write? Employee zip is determines to employee state and employee city. Now, when you are going to observe this employee zip again, depending on the employee ID. Yes or no?
Yes, sir.
Yeah. Now employee name also depending on employee ID. Okay, now when you are going to observe employee ID determines to employee name and employee zip. If you write, I will write here. Otherwise, ID determines to name comma zip. Correct? Yes or no?
Yes, sir.
Now zip determines to
State,
state and city.
city.
Now, if you observe, ID determines to name and zip determines to state and city. Now, is there any transitive dependency is observed or not?
Yes, sir.
Transitivity, yes. What is the transitivity? What is the transitivity? Tell me.
Like ID dependence on like states.
ID determines to name and zip determines to state and city. Then you can write directly ID determines to state and city.
State and city.
So that we got a transitive dependency. Now, as per the third normal form, this transitive dependency is not available in the relation. So that we need to decompose the relation. Here we need to decompose two relation. One is ID name, zip state city. Understand?
Yes, sir. Understood.
Means before that first normal form, you need to check first normal form. It is in a first normal form, second normal form. Yes, it is a second normal form. Now it is a third normal form. We are conformed. Now we are divided employee ID, employee name, employee zip, and employee state, and employee city. Clear?
Clear, sir.
Clear for this third normal form decomposing. Check. Is there any trivial dependency for this table and this
Clear, sir.
table now? After decomposition, is there any trivial dependency now?
No more, sir.
No. So that the given relation is Now it is in a
Third
given
normal
relation
form.
third normal form. Clear? All of you clear? All of you clear this?
Yes, sir. Clear. Clear.
Yeah. So if it is clear, then I will go for other examples. Right. Here one more example. Here student number, student name, student state, student country, and student age. Here can you tell any one of you? Here what are the functional dependencies are there here? First of all, you need to find the functional dependency. After finding the functional dependencies, you need to check that functional dependencies are having trivial functional dependency or not. If it is no trivial functional dependency, it is in a third normal form. It is any trivial functional dependency, you need to decompose. That is the what idea. Now tell me, is there any trivial functional dependency?
Yes, sir. It is.
Tell me, what is that?
From student number and student state.
Here, student name and student age. Hello? And student state are depending on student number. Yes or no?
Yes, sir.
Yes.
So that you can write the how to write the functional dependency. Here I am writing. Number determines to name, state, and age. Correct? Yes or no?
Yeah, yes.
Sir, even country.
Yeah, even country also we can write. Not a problem. But this country depends on what?
State.
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 Like state.
So that state determines to country. Now here is there any trivial functional dependencies available or not?
Yes, sir.
Yes, sir.
What is that? Here.
From student number and student age.
No. Here student number is determines name, state, age, country if you want, and state is determines to country. Now state is there and here is there. So that X determines to Y, Y determines to Z. So that we can write X determines to Z. So that we need to avoid this trivial functional dependency. Yes or no? Yes or no? Hello? Hello?
Yes, sir.
So that what happened? Student number, student name, student state, and student age you divide into one table, and state and country you divide into another table. Are you clear?
Yes, sir.
They're like this. Clear? Any doubt here? All of you clear? Is there any doubt? The simple mechanism is you need to avoid the trivial dependency. That you first know, then automatically you can solve the problem. Clear this?
Yes, sir. Clear.
Coming to another example, here employee table, here employee ID, project ID, performance score, and hike. So now tell me here, is there any trivial functional dependency or not? Before going to trivial dependency, go for the functional dependency. You know, ID determines, here what are the attributes?
Project ID. Performance score.
Project ID,
Performance score and height.
performance score, hike. Okay, this is fine because it's a primary key. But here, always the hike is depending on what?
Performance score.
Performance score determines to hike.
Hike.
Again, it is a trivial dependence, right? Pseudo transitivity. That is called
Yes.
the pseudo transitive. Already you know. Right now it is again the trivial dependency. Then you need to avoid the trivial dependency because third normal form is going to avoid the trivial dependency. Yes or no? What is that? That is performance score. Yes or no?
Yes, sir.
Here now. So this is what I got. Then we need to divide table into decompose table into two tables. What is that? ID. Hello, ID and project ID. Tell me. And performance score into one table. Performance score and
Hike in one.
another table. Clear this? Understood everyone?
Yes, sir.
Coming to another example. Tournament winners. Maybe this is another example I have taken. Here, tournament year, winner's date of birth. Now tell me here, the tournament year, winner's date of birth. The tournament name, year, winner's date of birth. Hello. Tell me. Hello. Hello.
It's depending on tournament.
Yeah.
So always this winner's date of birth is depending on winner. Yes or no?
Win.
Because if I know winner only, then I can know the winner's date of birth. Yes or no?
Yes, sir.
And you know the tournament and year we can write winner. Yes or no?
Yes, sir.
Yes, sir.
Because this winner is depending on tournament and year. This winner is depending on tournament and year. Yes or no? Because here individual Indian invitational, here also Indian invitation. We cannot tell this winner directly depending on tournament. So that that winner is always depending on tournament and year. So that I have taken tournament and year determines to winner. Yes or no?
Yes, sir.
Now this winner's date of birth is depending on what?
Winner, sir.
Winner. So that we need to write winner determines to
Date of birth.
winner's DOB. Now it is looking like X determines to Y determines to Z, correct?
Yes, sir.
Yes, sir.
So that it is having transitivity dependency. Don't think, that's why here every example I am showing different way. Here in this example, ID, PID and performance score and hike it is determining, and performance score is determining hike. Now left side only one attribute are there, but comes to here, left side maybe two attributes are there here. Observe.
Yes, sir.
Yeah, that's what. Don't confuse the things. Now, tournament year means tournament year directly we can write determines to winner. Yes or no? As per the
Yes, sir.
transitivity rule, Here, tournament
Sir,
comma
we
year
can.
determines to winner date of birth. Yes or no? Hello?
Yes, sir, we can.
Ah. So this is a transitivity. Now this relation is having transitivity, so that we need to decompose your relation into two relations. What are the relations? Tournament year, winner is one relation, winner and date of birth is another relation. Correct? Yes or no? Tournament year, winner is one relation, winner's date of birth is another relation. Like that you need to decompose. Yes or no?
Yes, sir.
Yes, sir.
Yeah, for after all decomposition, here already I told you, after decomposition you need to check two rules. What is that? Before decomposition you need to check what is the first rule? That relation is in suitable for which normal form? That is suitable for third normal form or second normal form or first normal form. Like that you need to check. That is the before decomposition. After decomposition you need to check again two things, two conditions. One is, tell me, what are the two conditions we need to check? Hello? What are the two conditions we need to check after decomposition? Dependency, preservation, and lossless time. Yes or no? After decomposition, using any normal form, you need to check dependency, preservation, and lossless joint. Yes or no?
Yes, sir.
Yeah, is there everywhere it is satisfying or not? Everywhere it is satisfying or not? Decomposition, preservation, and lossless joint, because one common attribute is there here. What is the common attribute? Winner. For second normal form also we did same, first normal form and third normal form also we are doing same. Yes or no? Hello?
Yes,
Hello?
sir.
Yeah. Now next example, here quickly. Uh, Here now coming to one more example, unit code, unit name, course code and course name. Can you tell what are the attributes or can you tell the functional dependencies now clearly? Please. Hello?
Course name depends on course code and unit name depends
Very
on
good.
unit code.
Course name depending on course code. 100%. Now, course code and unit name depending on the unit code. Yes or no? Yes or no?
Yes, sir.
Hello? Then how to write this functional dependency? Unit code use determines to unit name,
Unit
comma,
name,
course
Course
code.
code.
Now, course code determines to course name.
course name.
Now, as per this, here x determines to y determines to z. So that we have transitive dependency. So that we need to avoid this transitive dependency. So that we need to decompose two tables. One table is unit code, unit name, course code. Another table is course code and course name. Yes or no? Clear this?
Yes, sir.
Yeah. Now coming to another example. Student ID, student name, subject ID, subject and address. Tell me the functional dependency.
Student name depending on student ID.
Exactly. Student name depending on student ID. Is there any
Subject
other?
depending on subject ID.
Subject also depending on student ID. Address also depending on student ID. Yes or no?
Yes, sir.
And again,
Subject is depending on subject ID.
the things are there. Right? Sorry, I did one mistake, I think. What is that? Subject ID is depending on student ID and address is depending on student ID and subject is depending on subject ID. Even it is depending on student ID also, not a problem. Yes or no? Even everywhere, even this course name also depending on course code. Understand? If you want to write, you can write, not a problem. Hello?
Yes, sir,
Hello?
listening.
Yeah. Not listening, understand?
Yes, sir.
Yeah, now tell me the functional dependency for this. What happened? SID determines to SNAME, subject ID, and even you can write subject and address. And one more functional dependency is what? Subject ID determines to subject. Yes or no?
Yes,
Yes
sir.
or no? Yeah. Now what happened? Pseudo transitivity is there. Pseudo transitivity, you know already pseudo transitivity means X determines to YZ, then Z determines to P. Then we can write X determines to YP. Like that, this is a pseudo transitivity. The same mechanism is there here. Here, student ID determines to student name, subject ID, subject address, and subject ID determines to subject. So that we can write student ID determines to subject also. Yeah, this is a pseudo transitivity. So that we need to decompose relation to two tables. Yes or no? Yes or no?
Yes, sir.
Yeah. Now coming to one more. Here I am giving more examples for future convenience so that please understand the things. Next example, here ID, name, region, country. Now tell me, is there any functional dependencies? Tell me what is the functional dependencies?
Name depends on ID.
Yeah, name depends on ID.
Region also depends on ID.
ID.
Region also depends on ID. Even
Country
country
depends on,
also,
but it
Country
also
depends on
depends on region.
ID
even
and
if
like
you want to
region.
write ID, but directly it is depending on
T.
region, correct?
Yes, sir. Region.
Yeah, so that we have ID determines to name, comma region, and region determines to country. So that we have partial, the what I can tell partial functional dependency. That is what transitive functional dependency. So that we need to avoid this transitive functional dependency because our normal form accepts only non-trivial dependency. So that you need to decompose. What is that? ID, name, region into one table, region, country is another table. Yes or no?
Yes, sir.
Yes or no? Yeah. The last example for this third normal form. Here book ID, general ID. That is what general ID means that series ID and general type, what type of book it is, and the price. Now tell me the functional dependencies here. What are the functional dependencies here? This table.
Like type depends on ID.
This general ID also depending on the book ID because which category of the book it is. Maybe the sports category or a health category like that. And then price also depending on the book ID, correct? Yes or no? Even yes or no?
Yes, sir.
Now this category of book is depending on category ID.
Yeah.
Now, if you observe what happened, BID determines to genre ID and price. Correct? Is it right? Hello? Hello?
Yes, sir.
Yeah. Now, genre ID, nothing but a category ID, is determines to G type, means category type. Now, again, X determines to Y determines to Z. So that so there is a transitive dependency. So that we need to apply third normal form to avoid this transitive dependency. Clear? So that we need to decompose the relation. Your BID, GID and price is one table, GID and GT is another table. Yes or no?
Yes, sir.
All of it, yeah. Now all of you clear about this
Yes.
third normal form with examples?
Yes, sir.
Yes, sir.
Yeah, please try to please apply first, second, and third normal form on your relations for the as a third experiment in the laboratory. By Saturday we have laboratory, right? In that you finish up that particular uh, uh, experiment. Then you do it. Any doubts is there? We will discuss on Saturday for applying of these normal forms. Okay, but practice it.
Okay.
Yeah, please. Sure, without practicing, we cannot learn. Your practice